Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle. And it's called Cage Play 2 RenKiller by Half-Baked Lunatic, aka David Workman. And here are the rules. Normal Sudoku rules apply, which means fill the entire grid with the digits 1 through 9 such that there are no repeats in any row, column, or designated 9-cell regions, which are boxes here. We also have digits in cages summed to the number in the corner, if given. And digits do not repeat within cages. So this is normal killer Sudoku rules. So for example, these two digits must add up to 17, these 4 must add up to 19, these 6 must add up to 28, etc., etc. And you cannot have repeats within cages either. And the final rule is for groups of cages connected by a purple line, cage sums form a consecutive set of numbers in any order. Oh, interesting. So cage sums form a consecutive set of numbers in any order. So that means the cage sum of this is consecutive. There are 1, 2, 3, 4, 5, 6, 7 cages on this RenKiller line. So the sums of the cages along this RenKiller line must form a consecutive set of numbers and can be in any order. So this is like Renban, except that instead of digits, it's cage sums, which must be a consecutive set. So you could have something like, for example, on this one, you could have something like 7, 8, 9, 10, 11, 12, right? Actually, it would be longer than that. Okay, let's look at this one. Actually, let's look at this one. One of the cages has a sum of 17. That means the sum of all of these cages must be either 14, 15, 16, 17, 15, 16, 17, 18, 16, 17, 18, 19, or 17, 18, 19, 20, because it has to form a consecutive set of numbers in any order. And that's how RenKiller lines work, which is why this puzzle is called RenKiller, because it's a combination of Renban lines with killer cages. And so the Renban lines designate the sums, which have to be consecutive, of the cages. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, the one that comes out to me is this cage has to be add up to 17, so it's 8 and 9. That means this can never be 8 or 9. So this is at most 7. And the thing is, to form a Renban, it has to be at least, well, okay, what is this digit? 7 can be with 9. That could be 16. 6 could be with 9. That would be 15. And you can go down to 14. So it could be 5 with 9. So I think this has to be 9 no matter what, right? This is always 9, right? Because you cannot have, if you had 7 here and 6 here, which is the most that without a 9 this cage could be, that would be 13. But you have, this is 4 in length for this Renban, and that's 17, 16, 15, 14 at most. So this is always a 9 here. This is 5, 6, or 7. So if this is 9 and 5, what would that form? 9 and 5 is 14, so that would make this 31. But this is on a RenKiller line with a 28 cage, so it can never get to 31. So this can never be 5. It's 30 this is either 15, which makes this 30, and this would then be 29, or this is 16, which makes this 29, which would make this either 27 or 30. We're not sure which. So this is either 27, 29, or 30. We're not sure which. This goes through 1, 2, 3, 4, 5, 6, 7 different regions, cages, right? 1, 2, 3, 4, 5, 6, 7. And we have a 5-cell region here and a 1-cell region. So that means this is, well, can this ever be 7 is kind of the question. If this were 7, you'd have to have 8, so 7, 8, 9, 10, 11, 12, 13, that's 13. The most of the sum could be 13, but we know a 5-cell cage must add up to 1 plus 2 plus 3 plus 4 plus 5, which is 15. So if you have 7, you have 8, 9, 10, 11, 12, 13. So that's not possible to start with 7. So this has to be 9. So this is a 9. And therefore 9, 10, 11, 12, 13, 14, 15. And we know this is 15 at minimum. So this has to be 15 here because there's only 7 cages on this line. And so one of them has to be 15. If this is not 15, unfortunately it would have to be 14 or less, and that's not possible. So this has to be 15. So this is 1, 2, 3, 4, 5. So no 2. 1, 2, 3, 1, 3, 4, 5. And 5 cannot be here. That leaves the remaining digits. This can't be 6, 7, or this can't be 9 here. So this has to be a 9 here. That leaves this as 6, 7, and 8 here. So we have a 6, 7, 8 triplet here. That must add up to at least 13. What else do we have here? That leaves the remaining digits as 1 through 5 in the rest of column 3. This can't be 3. This can't be 4. This combination has to be 1 through 7 without a 6, and 2 cannot be here. So 2 has to be here. This has to add up to at least 10. So this has to have a 7, right? If you don't have a 7 here, this would be only 4 and 5 at most, which is 9. And that doesn't work with this RenKiller line because it must go from 9 to 15. So this has to be 7, which means this can't be 7. This is either 10, 11, or 12. Okay, so the combinations then are... Okay, so this adds up to 23. This has to be 10 and 12 then, right? 45 minus 23 is 22. You can't have 11 and 11 because, again, they form a consecutive set of numbers in any order. So it has to be either 3 and 5 here, and this is 3 or 5. So this is 10 and then 12. So the rest of the digits cannot add up to 10 or 12. Sorry, the rest of the cages cannot add up to 10 or 12. Because we know 9 is minimum here and 15 is maximum. So it must go through the full length. So this cannot add up to 10 or 12. We have 11, 13, and 14 possible. So this is 13 or 14. So it cannot be 7, 8. So it has to be 6 with 7 or 8 here. This is 5. We have to have 11. It could have 1, 2, 3 here to form 11. Or this adds up to 11, which is more likely. We cannot have 12, so it's 11, 13, and 14 are the possibilities. 9 cannot be here. 9 is one of these digits here. We have 6 and 7 here. But this can't be 6. So 6 has to be here. We have how many cages do we have here? 1, 2, 3, 4, 5, 6, 7 cages. So that could go down to 13, I believe. 13, 14, 15, 16, 17, 18, 19. Yep, that's 7 digits. That's 7 cages. Or up to 25? Right. Hmm. Hmm. Okay, let me get a calculator. We know all these cages with the number, with these digits must add up to 45 times 9, which is 45 plus 30, 360, which is 4 of 5. Do I want to do it that way, though? I don't know. 7 is here. 7 has to be here. 7 is here. 8 has to be one of these 3. 9 is also one of these 3. Interesting. 8 cannot be here. So 8 has to be one of these 2. We can't have 6 and 8. Okay, what are the sum of all these cells? Or cages. So we can get... Let's get an... Okay. We're going to get a calculator. These are 7 cages, which is at minimum 13 to 19. Maximum 19 to 26. Okay. 13 plus 14 plus 15 plus 16 plus 17 plus 18 plus 19 is 112. That's the minimum. Huh. And it includes this. So, you add 4, 6, 3, and 8. That gives you 133 for this set. here. That's pretty broad. Okay, we know guaranteed what this set is, right? It's um 9 plus 10. Right, we know what that is. We know essentially what this could be. Right, this is pretty minimal. Okay, so we know these cages are 9 through 15. So 9 plus 10 plus 11 plus 12 plus 13 plus 14 plus 15. That's 84. Plus 6, 8, and 4. That's 102. Plus for these three here, it's 20. It could be 28, 29, 30 at most. Or 27, 28, 29. Let's do the minimum for now. So 20, whoops. We have 102 plus 27 plus 28 plus 29. I'm not sure if this is the best way of approaching it. Let's see. What else can we do? This has to be 11, 13, or 14. This is 11, 13, or 14. If this is 13, it's 6, 7. Okay. Let's look at it this way. This is 15 or 16. If this is 15, this has to be 30, which forces this to be 29. Actually, let's do remaining digits in row 1 and column 8. We have 1, 2, 3, 5, 7 here. This can't be 3. And we have 1, 2, 4, 5, 7 in column 8. This can't be 5. This can't be 2. These digits are 1, 2, 4, 5, and 7. And, okay, I see it. What's the maximum this could be? Actually, what are the values this could be is kind of the question. So this can't be 4 here. I think this has to have a 5 and a 7 here. Well, okay, yeah, you can't... So, say you don't have a 7 here. What's the maximum this could be? 2, 4, and 5, which is 11, which is well off from 17. It's not 3 or less away from 17. So this always has to have a 7, which means this can't be 7. This is 6. This can't be 7. Can you have 2, 4, and 7? That adds up to 13, which is not 3 or less away from 17. So this has to be at least 5 and 7 here. And 1 cannot be here because 1, 5, and 7 adds up to 13. So it's either 2, 5, 7 or 4, 5, 7. This is 15, actually. So 5 cannot be here. So this is 1 through 4. This is 1 through 4 here. This has to be 1, 2, and 9 or 1, 4, and 9. We're not sure which here. So 1 is here, which means this can't be 1. This is 30, so this must be 29. Since this is 29, these three digits must add up to 45 minus 29 minus 4, which is 12. You could have 1, 3, and 8. You can't have 147. You can't have 156. You could have 237. You can't have 246, and you can't have 345. So this has to be a 3 no matter what, it looks like. Which eliminates 3 here, and 3 can't be here. This can't be 1. So 3 has to be here, right? We can't have anything with 6 or 4. So that eliminates, you can't have 9 either. So no 129. No, you could have 138, no 147, no 156. You have 237. You can't have 246. You can't have 345. So 3 does have to be here, which means 3 cannot be here in the rest of the box. 9 has to be one of these 3. That's fine. So we know the exact amount here, too. So we can actually go back to our calculator. We know this is 9 through 15. This is 28 through 30. So that gives, and this is 15 and 17. What is this? This also, I think, has to be either 247. Can you ever have 3? We have 15 here. I guess it could be 347 here. That is possible. You cannot have a 1 because 1, 5, and 7 at most only adds up to 13. So 1 is not here. Where's the 1 in column 9? It has to be one of these two cells. So 1 cannot be here. 1 is one of these two cells here. 3 is here. This could be 3, 4, 7. Either way, the 7 does have to be one of these two digits, because if it's not, the problem is, what's the max this could be? 3, 4, and 5. Which would be 12, which is too small for this. So this has to have a 7. It could be 3, 4, 7, 4, 5, 7, or 2, 4, 7. 9 is one of those 3. So we know what these add up to. And we know what these add up to. And we can add these in. And we know what that adds up to. We have a good guesstimate of what this is. So that will tell us what these must add up to. Okay, so let's add those up. We have 9 plus 10 plus 11 plus 12 plus 13 plus 14 plus 15. Then we have 28, 29, and 30. We have to add 4, 6, and 8, the single digits. We have 15 and 17. And it's either 14 or 16 in this cage. So let's just add 16. That's 237. Actually, let's add 14. So I'm going to subtract 2. 235. That means these 6 digits must be 6 times 45 minus 235. So 6 times 45 minus 235 is 35. These add up to 135. So if we add 135 to 35, So that was assuming this is 14. So this would then be 16 if that's the case. So 170 minus, we know it's 16 here. Then we subtract 3684. Which is 133. Right, because this does have to be 14, 15, 16, 17. We know that for certain. Okay. So that tells us actually exactly how much this is. So let's make sure we calculate, or exactly how much this space is. So let's try calculating that again. We know this is 14, 15, 16, 17, because this is 15. This can be at most 14, or sorry, at most 16, and this can be at most 16. So therefore, one of them's 16, the other one's 14. So again, we have 9 plus 10 plus 11 plus 12 plus 13 plus 14 plus 15. We have 14 plus 15 plus 16 plus 17. We have 28 plus 29 plus 30. We have an additional 4, 8, and 6, and then a 3, 6, 8, and 4. Oh, so that's 233 plus 39. So that would be 405 minus 272. So that is 133. So we've calculated that correctly. So let's say we subtract 19 from that. Let's say we subtract 20. Well, we have to go down to 17 at least. So 19, 20, 18. Okay, so we have 133 minus 17 at least, 18, 19, 20, minus 21, minus 16, and 22. So it's 16 to 22 are the sums that we have. So this is 16 to 22 for this RenKiller line. So this can never be 7, because if this were 7, that would force this to be 7, 8, and 9, which is 24. And we know this adds up to 16 through 22. So this is 16, so this is either 9, 8, or 9, 7. It can't be less than that. So this has to be an 8, 9 pair then. Which means this can't be 9. This can't be 7 because that would force this to add up to 24, which is too much. So we have the 17. This is 6 and 7 pair. This is 1 through 5. This is also 1 through 5, but it can't be 4. It's 16 or 18 here. So this can't be 1 or 2 here. This is 3 or 5. Right? 6 and 7 with 3 adds up to 16. 6, 7 with 5 add up to 18. That means where's the 1? This is a 3, 5 pair, which eliminates 3 and 5 in the rest of the column. So that must make this a 1, 4 pair, which eliminates 1 and 4 in the rest of the box. This can't be 1 or 4, so this is 3, this is 5. This can't be 3 anymore. This can't be 3. And it can't be 5. We have a 1, 2, 4 triplet here. This adds up to 19. One of them is 3 or 5. Well, one thing you cannot have is 1, 2, 3 here. Can you have 1, 2, 5 here? No, that adds up to 8 at most, which would make that single digit 11, which is not possible. So this can never be 4. That makes this 1, 2, so 4 has to be one of these two, so this can't be 4. That means 4 is one of these two. It cannot be 2, 3, 4, because that would add up to 9, and this would then be 10. So even if this is a 3, that doesn't work, because it would be 2, 3, 4 at most. So this has to be 4 and 5, which forces this not to be 5. So this is 3, which means these can't be 3. That's 3 in the corner. We celebrate because we know we're getting close to solving it. This can't be 3. This is a 5, 7 pair, which forces this not to be 5. Whereas the 3 in column 3, it has to be here. So this is 3, which means this can't be 3. It can be 1, 4, 5 if this is 9. It could be 2, 4, 5 if this is 8. So this is 8 or 9 here. We then have an 8, 9, 8, 9 pair in row 7, which eliminates 8 and 9 in the rest of the row. This can't be 9. This has to be 12. This is 10. This adds up to 17. This is 16. So we have 16 and 17, which means we 19. So we need 18, 20. This can so this is 16, this is 17. We have 19 here. This can never add up to 20 because 2 and 8 and 9 only add up to what is it? 2, 8, and 9 adds up to at most 19. And we already have 16, 17, and 19 taken. So this has to be 18, but it could be either 1, 8 or 2, 7. Either one works. That means this is 8. We have 16, 17, 18, and 19 taken. We need 20, 21, and 22 here. Okay. This 5 eliminates 5 here. What does this have to have here? Again, this is 10, this is 12, 15, this is 13 or 14. One of these is 11. So it could be 1, 2, 3, 5. If this is 1, 2, 3, 5, this is 16 or, sorry, this is 13 or 14. If it's 13, it's 6, 7, which forces this to be 6, 8, which makes that 7. So this would have to be 6 and 7 there. Right? If this is 13, this becomes 14, 6, 8, so that's 7. So this, the other way around. This is 6 and this is 7, if that's the case. If this is 14, that makes this 13. If it's 14, it cannot be 5, 9, it must be 6, 8. In either case, this is 1, 2, 3. Obviously, this can't be 2. So if this is 14, it's not 5, 9. It has to be 6, 8, which forces this to be 6, 7. So this is 8. So this is 6, and this is 8. Or this could be 11. If it's 11, it could be 2, 9, or 3, 8. It cannot be 4, 7, or 5, 6, because those are eliminated by the 4 in the column or the 5 in the box. 5 is one of these two. We have 20, 21, and 22 in these three cages. We have interesting information here, right? So it's 19 plus 17 plus 16 plus at least 20 and 21 plus 4 plus 6 plus 3 plus 8 plus at least 14. So these two digits by themselves can only add up to at most 135 minus 128, which is 7. So that means this is 1 through 5. Cannot be 4, though. Does that tell us anything? Not particularly. If this adds up to 14, this can never be 9 then. It can add up to at most 14 with a 5. So 14 minus 5 is 9 at most. So that would be 1, 2, and 6 possible. You cannot have a 4. So this can never have 7 and 8 here. Right? Because this is 14 at most. 5 and 7 add up to 12. That would leave 2 at most here, which 2 digits can never add up to. So this is 1, 2. So we know we're guaranteed a 1 and a 2. I guess it could be, no, it can't be 136. 136 adds up to 15, which is not allowed. So 1 and 2 both have to be here. So we have 1 possible here, 2 possible here. Which means the remaining digits in that column cannot have 1, 2, 4, 5. But it could be 3, 6, 7, 8, and 9. This can't be 3 because of that 3. Or 3, 6, 7, 8, and 9. And this neither of these could be 3. Okay, well, we're guaranteed then this has to be 1, 2, and 3. Right? There's no other place for the 3. 3 can't be here because this can't add up with these digits to add up to 19. 3 can't be here for this 3 and this 3. 3 can't be here because of that 3. Therefore, this is a 1, 2, 3, which forces this to be 11. And since this is 11, this has to be 13 or 14, which makes this a 6. This cannot be 9. We have a 6 here. One of these is a 6. It's a 7 or 8. Hmm. Okay, 28 without a 5 with 6 digits. Okay. What's the minimum? 1, 2, 3, 4, 6, 7. That adds up to 23. So we have 5 degrees of freedom, which we need to gain. Actually, what is this value? We know this is 15, so this is 30. This is 29. So this is 12 at most. Well, actually, it's exactly 12. So this is 11 at most, which means this is at least 17. Oh, we know there's a 2 here because 2 cannot be any of these. 2 can't be here. So 2 has to be here, which means this can never be 2. That's interesting. So it has to have a 2. Does it have to have a 1? What's the minimum without 1 and without 5? It's 2, 3, 4, which is 9, plus 6, 7, 8. So no, it cannot have... Right. So 2, 3, 4, 6, 7, 8. 6, 7, 8 adds up to 21. 2, 3, 4 adds up to 9, and that does not add up to 28. So this has to have a 1 somewhere. Can it have no 4? Because it doesn't have a 4 here. And if this is 1 here, that would make that 4. So therefore, there would be no 4. So that would be 1, 2, 3 at minimum. 6, 7, 8. So that does work. 1, 2, 3, 6, 7, 8 does work. What if you have a 4? If the 3 is not here, what is that then? It would be 1, 2, 4 at minimum. 6, 7, 8, which is not allowed. So you have to have 3 there. Right? Without 3, you have 1, 2, 4, 6, 7, 8 at minimum. 1, 2, 4 adds up to 7. 6. Oh, wait, no, that does work. No, it actually has to be 1, 2, 4, 6, 7, 8. Is that the case? No, you could have 1, 2, 3, 6, 7, 9. Right, so you could have 1, 2, 3, 6, 7, 9, or 1, 2, 4, 6, 7, 8. And I think those are the only possibilities. Can you have 1, 2, 3, 4? No. 1, 2, 3, 4 adds up to 10. So that would require 2 digits adding up to 18, which is not allowed. So it is 1, 2, 3, 1, 2, 3, 6, 7, 9, or 1, 2, 4, 6, 7, 8, adding up to 28, right? 6, 7, 8 adds up to 21, plus 1, 2, 4 adds up 7 to add up to 28. 6, 7, 9 adds up to 22, plus 1, 2, 3 adds up to... And we know 5 cannot be either of these places, because 5 doesn't add up to these to add up to 12. So we need a 6 here, and 6 cannot be here because of this 6, so 6 can only be here. This is 6, which means this can't be 6 here, because 6 can't be here because of that 6. This must be a 6 then. We know one of 7 or 8 is here. We have to have... one of these is 7, but that doesn't really help much. One of these is 7, 8, or 9 here. But we have 1, 2, 4 as a possibility also. Remaining digits here, we have 1, 3, 4, 7, 8, and 9. This can't be 1, because one of these is 1 guaranteed. Can't be 9, because 9 and 8, because 8 and 9 cannot be here. Ah, that makes this 3, 4, or 7, which means this cannot be 3, 4, and 7, adding up to 14. So it has to be 5 and 7 here, and then 2 or 4 here. So this is 2 or 4 with 7 and 5. This can't be 5. That eliminates 7 here. This can't be 7. This is 8, which makes this 14. So this must be 13. So it's 6 and 7. This is 7. This is 8. 8, 9, and 1 add up to 18. So these can't be 1. This has to be 2, 4, 5, which is 11 plus 8, adding up to 19. So this is 9, this is 8. 8 cannot be any of these. 7 cannot be here. We need a 7 on... This can't be 8. This is a 1, 2, 4, 9 quadruplet. So that eliminates 9, 1, 2, 4, 9 from the rest of the row. So this is 8, this is 9. This then must conclude a 9. So it has to be 1, 2, 3, 6, 7, 9. So this cannot include a 4. So it's a 1, 2, 9 triplet, which eliminates 1, 2, and 9 in the rest of the cage and the row. So this can't be 1. This is 4. This is 1. This cannot be 1 and 8. It has to be 3, 7. Because it's 1, 2, this is 1, 2, 6, 9. That adds up to 18 here, so this must add up to 10. So this is 2, 3, and 7. This can't be 2, so this is 1. This can't be 1 or 2, so this is 4, which makes this a 2. This 7 eliminates 7 here, so it's 5 and 7 here. This can't be 7 or 2 and 7 here, which makes this a 1, 5 pair. This makes this 6, 8, and 9. This can't be 8 here, though. Where is the 8 in that box? It has to be here. This 2 eliminates 2 here, and it can't be 1 here, so this must be 3, which forces this to be 1. That eliminates 1 in the rest of the box, and 3 and 9. So this has to be a 4, 7 pair. The 7 eliminates 7 here, so this is 4, which makes this a 3. What's left here is a 7, and then we have a 2, 4 pair, but 4 cannot be duplicated in the cage, so this 4 means this can't be 4. This is 2. This is 4. This cannot be 4, 5, and 7. It's 2, 5, and 7. So this is adding up to 14 here, 16 here. This can't be 2 or 4, so this is 1. This can't be 1 or 2 now, so this is 3. That's 3 in the corner. We celebrate because we know we're getting close to solving it. You cannot have 5 anymore here because of the 1, 5 pair in the row. This can't be 2 because of this 2, so this must be 7, which makes this a 2. This can't be 2 or 7. It can't be 5, so this must be 4. This 2 eliminates 2 here, so that's a 1. That leaves this. This can't be 8, so this must be 8 here, which leaves this as a 5. This 2 eliminates 2 here. This is 2, 3, 4, 7. This 1 eliminates 1 here and here, so this is 4. This can't be 1. This can't be 4. This can't be 8, obviously, because of that 8. So 7 has to be one of these two. This can't be 4. 2, 3, 4, 7 adds up. Well, this cannot be 2 and 3 because you can't have duplicates in the same box. So this must be 5 then. So this is 5. This is then 2, 3, 4, 7, 5. That gives us 9 plus 5 plus 7, which is 21. Okay. So this 5 eliminates 5 here. That makes this a 2. This can't be 2 or 5, so that's 7. That leaves this as a 3. This 7 eliminates 7 here. It's 3 and 7. This 5 eliminates 5 here. It's 1 and 5. This can no longer be 9 here because of the 9 in the box. So this must be 2. Sorry, this must be 9. And this must be 2. This 6 eliminates 9 here. So this 6 eliminates 6 here. So it's 9, 6. And this must be 7 or 9 here. This has to be 2. This 2 eliminates 2 here, so it's 5 and 4. This has to be 2 and 6 remaining. This is 3 and 1. So 1, 3, 7, 9 adds up to 20. 1, 2, 4 and 6, and 9 add up to 22. 2 and 6 add up to 8. 1, 4, 9 add up to 14, which is 22. So we just fill out the rest with just normal Sudoku. This 1 eliminates 1 here, so it's 9 and 1. 9 eliminates 9 here, 7, 9. These can't be 7. This 5 eliminates 5 here, so it's 2 and 5. This 2 eliminates 2 here, 6 and 2. This must then be 6 and 7. Yeah, I mean, not really difficult, I would say. It's a lot of math. That's all I would say. It's just a lot of math. Yeah. I like generally killer cages, so this was fun for me, but I hope you had a good time too. And I'll see you next time on Frank Puzzles. Take care.